This lecture focuses on strategic highway safety plans and broadly the ways that transportation agencies try to prioritize at a high level both short-term and long-term safety investment strategies. Okay, and so we'll start with a brief overview of some fatal crash statistics, including some comparisons between Michigan and other states, as well as US trends. We'll then talk specifically about strategic highway safety plans, and that will include coverage of the national plan that was developed by the American Association of State Highway and Transportation Officials, as well as Michigan's SHSP, which was developed with leadership from the Michigan Office of Highway Safety Planning and various other stakeholders. And then we'll wrap up with a brief introduction to highway safety improvement programs. And as a reminder, assignment 1 is due by midnight on Friday. Okay, so we had presented a similar graphic last week, and this just basically demonstrates the magnitude to which traffic safety is a huge societal problem. And so nationally, we've got roughly 13 million crashes on an annual basis. Just under half of those are generally reported to law enforcement for various reasons. And if we look at the economic costs associated with these crashes, considering just purely economic costs, so things that we can explicitly quantify, that would be things like the costs for treating injuries, for vehicle repair, for clearing the scene of an accident, insurance costs, basically anything that we can assign a direct dollar value to. Those costs are nearly $250 billion. When we include broader costs, including things like pain and suffering, impacts on the families of those involved in the crash, a wide range of other factors, which are referred to as comprehensive crash costs, then we're much closer to $1 trillion, frankly. And so this just reinforces the magnitude of these issues. And I should note these numbers have gone up a bit since 2015 when this graphic was developed. So we're really demonstrating here just how big of a problem this is nationally, and the same is true internationally, of course. Okay, and so you've also seen a chart similar to this previously. So this is just basically demonstrating what the trends have looked like over time, both in terms of the number of traffic fatalities experienced across the US on an annual basis, as well as a normalized rate per 100 million vehicle miles traveled. Now, if we focus just on the raw number, we see that since 1975, we've reduced from just over 44,000 to around 36,000 fatalities. And that number has gone up a little bit in 2020, interestingly, even though we're in the midst of a pandemic. And so what you generally see here is fluctuation that's driven in large part by increases or decreases in how much people are traveling. You'll notice in recent years that those numbers have started to creep up again. And when we look at the rate per miles traveled, the story has been somewhat more positive. So we've generally seen persistent declines in the fatality rate per 100 million vehicle miles traveled. Now, one quick point of caution there, though, if we think about the traffic growth that has occurred, a lot of that traffic growth has focused on long distance, high speed travels. And so those would be trips that typically occur on our interstate system, which has the best safety performance in terms of crashes, injuries, and fatalities on a per VMT basis. And so we need to dig a little bit deeper to get a better understanding of what's happening here. But even when we look at the rate normalized per how much people are traveling, you'll notice that has largely plateaued for the last 10 years or so. And so while we have the promise of some emerging safety features, self-driving vehicles, a lot of the advanced driver assistance systems like forward collision warning, automatic emergency braking, lane departure warning systems, etc., it'll still be a little while until it looks like we see sustained and pronounced impacts there. And so there's quite a bit of work to do still from the traffic safety perspective. Okay. This is an interesting graphic. This is basically, if we look at all of those fatalities over that 45-year time period, the percentage of those that involve fatalities that occur inside of a passenger vehicle and outside of a vehicle, and outside of the vehicle would refer to crash-involved parties such as motorcyclists, pedestrians, bicyclists, etc. And what you see generally speaking here is that those numbers had declined persistently until the mid to late 90s. And a lot of that is just simply reflective of how much people were driving versus engaging in some of these other types of vehicle use. Now, since that time, there have been dramatic increases in motorcycle registrations and motorcycle VMT for various reasons. There have been a number of programs that have been focused on increasing the degree to which people walk and bike, whether that's for work or school or recreational purposes. And so that's coincided with a significant increase in the proportion of fatalities that are sustained by these most vulnerable road users. And so this really continues to be a significant dilemma, and one for which we don't have a lot of great answers at present. There have been a number of initiatives and some countermeasure programs that have focused on peds and bikes, for example. And in Michigan, we have examples of complete street policies where we're starting to introduce some infrastructure to accommodate and help to protect these more vulnerable users. But again, this trend has been pretty consistent and is forecasted to continue in the near term as well. So a few things to be mindful of there. This is one of the more interesting graphics from this summary of the fatality analysis reporting system. And this is basically just showing us, in terms of rural versus urban land use areas, what's happened to fatality trends over time. And so over the last 10 years, we've basically seen a flip in terms of the proportion of fatalities that occur in rural versus urban environments. A lot of this has been driven just by changes in terms of where people live and work. And so in contrast to really the 50 to 60 years prior to this chart, when we had seen, generally speaking, people moving away from cities in large part towards suburbs and outlying communities, a lot of people have started moving back into the cities. And with that, there have been increases in traffic, and a lot of that has coincided with increases in crashes and, as illustrated by this graphic, increases in fatalities. Okay. One of the longest standing concerns that has been a particular challenge to address is that of drunk driving. And so looking at this chart right here, this is basically telling us, if we look at all fatalities on a state level, the percentage of those that involve impaired driving. And so the big thing that this demonstrates is, if we could solve the drunk driving problem, we could eliminate roughly 10,000 of the nearly 40,000 fatalities that occur nationally each year. And you'll notice from this, part of this could be improved through policy measures. So Utah is notorious for being a dry state and having dry counties that either prohibit or significantly inhibit consumption of alcohol. And that's reflected by the fact that less than 1 in 6 roughly fatals involve alcohol, as compared to various neighboring states here, with the worst states on a percentage basis being generally very rural Western states. And so in these cases, the amount of alcohol consumption is exacerbated by the fact that it simply takes longer to respond to these crashes when they do occur. And so you really have a negative mix of factors here that really help to exacerbate this problem, unfortunately. And this is one for which there aren't a lot of near-term solutions. We lag behind a lot of other countries, and part of that is due to the fact that we consume more on average in terms of alcohol from neighboring countries, but even among those that consume similar amounts on a per capita basis, we travel a lot more. And so there's simply more opportunity here, and we don't have nearly the negative stigma or the harshness of penalties. We've got cases in the US where people have been convicted of drunk driving 19 times. And so that's an issue that remains to be addressed, and one that we'll talk about further over the course of the semester. Okay. It's also somewhat interesting when we compare Michigan to some of our neighboring states. And so just some quick context here. We see a solid light blue line. This is basically looking at overall national fatality rates per 100 million VMT. And you'll see that number has generally been trending down and then plateauing, as we saw in some of the preceding graphs. Directly above that, so this is also fatality data reported by the National Safety Council. And so the reasons for these discrepancies is that the FARS data only includes fatalities that occurred directly as a result of a motor vehicle crash within 30 days of when that crash has occurred. So there are a number of cases where people are fatally injured, but that death doesn't occur until outside that 30-day window. And so that's not an insignificant number of fatalities. Generally, it's going to range from between 2,000 to 4,000 deaths per year. And that helps to explain the difference between these charts. Now, if we look at Michigan specifically, it's in the light purple. And so you'll see over much of this period, we perform better than some of our peer states here in the Midwest, although that's really changed starting around 2010, 2011, 2012. Unfortunately, this truncates at 2014. But if we extrapolate this forward, we're still in that same general group. The one major outlier here is actually the state of Minnesota, which has consistently shown significantly better performance. And there's still unclear what exactly is so different about what's being done in Minnesota. But they are an example of an early adopter state in terms of Vision Zero and Towards Zero Death. And so large programmatic efforts that are oriented towards significantly reducing the number of traffic fatalities we experience in the US. Okay. And so strategic highway safety plans have been around for only about 15, 16 years now at this point. The first national plan was developed back in 2005 by AASHTO, as noted previously. And since then, as you may recall from the prior lecture on legislative acts, we have actually seen a federal mandate that each state is responsible for developing, updating, and regularly maintaining a strategic highway safety plan. And so if you go to this link, you can basically find out anything you would want to know about best practices, obtain access to any of the state plans, and learn more about the general process by which these plans are ultimately developed. And so here in Michigan, we had actually helped to develop a plan back in the 2013-2014 time period, and subsequent updates have largely been done by OHSP in coordination with MDOT and some other partners. But we do have some direct input into some of these decisions through research, through direct involvement in some of the committees and action teams at the state level. And so we'll talk a little bit about some of the mechanisms we can use from a big picture perspective to try to improve safety as we continue through today's lecture. Okay. And so as per those federal requirements, there are a few minimum stipulations for strategic highway safety plans. The first of those is that the plan needs to be data-driven. So if we look historically, safety has always been at least an implicit consideration in highway design when we think about designing roadways that would meet minimum criteria and guidelines as per the AASHTO Green Book or the Manual on Uniform Traffic Control Devices. But only relatively recently, over the last 10 to 15 years, particularly, have we seen the Highway Safety Manual evolve and for states to become more quantitatively based and proactive in terms of how they make safety investment decisions. And that's been driven at least in part by some of this federal legislation we had referred to. In addition, it's important that these plans are developed in collaboration with a broad range of stakeholders. We'll talk about that a little bit more on the subsequent slide. But as engineers, we have impacts over certain aspects and influence over certain things that affect safety. But there are a myriad of factors of which we have either indirect effect or little influence on. And so that's why it's important that these plans are developed in a collaborative nature. To that end, we like to have the plans be multidisciplinary and address the 4 E's of highway safety. And so that gets back to the collaboration point. Those 4 E's being engineering, education, enforcement, and emergency medical services. And we'll talk on subsequent slides about some of the programs, policies, and countermeasures that are implemented across those different domains. We also need the plan to be performance-based. So in addition to leveraging data, we're focused on establishing goals and objectives that are measurable, and that in turn the FHWA or the federal government can then review states' performance and things like funding decisions and how much tax money goes to a given state, at least in small parts, can be incentivized on the basis of hitting some of these performance metrics. And so that's another item that's evolved relatively recently. Performance measures and data-driven safety analyses have become big buzzwords, and states are doing a much better job of doing things that are more quantitative rather than qualitative in nature in terms of establishing and maintaining these safety programs over time. Lastly, we need to make sure that these plans are developed in coordination with other highway safety plans, and we'll talk later about the Highway Safety Improvement Program. But there are also, as I had alluded to, at the national level, there's an AASHTO, Strategic Highway Safety Plan. In Michigan, there are regional plans that have been developed in leadership from MDOT largely. And in other states, such as Iowa, for example, each county actually has its own highway safety plan. And so, generally speaking, it's good if the objectives are consistent and coordinated across those plans, because that helps to enact more large-scale change and greater consistency in terms of the types of emerging issues that are being addressed through these planning mechanisms. Okay. Now back to the 4 E's of traffic safety. So from an engineering perspective, obviously design plays a big role here. We talked a little bit previously about nominal safety and ensuring that we meet the minimum requirements. So the 10 controlling criteria outlined by the Federal Highway Administration, for example. There are also rigorous standards in place for construction and work zones, as per the MUTCD, for example. The MUTCD also provides guidance and or standards for things like traffic signals, signs, pavement markings, etc. So different ways we're trying to influence drivers' behavior. And in addition to that, one of the other key roles from an engineering perspective is some of the safety-focused research that we're working on. So this leads to things like changes in design guidance, like the AASHTO Green Book, for example, or in the types of policies and programs that are implemented by state DOTs. So we're currently helping MDOT to refine the processes by which they plan and program projects, specifically as it relates to some of the non-motorized users we had referred to previously. And so a lot of the actions we can take as engineers are focused obviously on the roadway system. Unfortunately, regardless of how safe we design those roads, we're largely at the mercy of how people tend to drive. And so that's where some of the other 3 E's of traffic safety come in here. So from an educational standpoint, the primary tool that we think about in this domain is driver licensing and training programs. And so that would include things like specialized training for commercial motor vehicle drivers, or perhaps the greatest success story in this domain over the past 20 or 30 years has been graduated driver licensing programs, which weren't in existence when I was in high school back in the mid to late 90s, but are now commonplace in every state in the US and much of the world. And those have been shown to significantly dampen the heightened crash risks that are posed by younger drivers. Beyond formal training, education also includes various types of public awareness campaigns. And here in the state, you've probably seen examples of campaigns targeted towards behaviors like drunk driving, driving without a seatbelt, distracted driving, so forth and so on. And so in those cases, educational campaigns and public awareness and outreach can have some effect, but it's really best used as a supplement to some of these other activities that we're talking about on this same slide, one of which would be high visibility enforcement. And so enforcement is going to be critical to ensure that drivers are following the rules of the road. So things like speed limits, generally speaking, compliance is maybe not what we would necessarily like from a speed selection standpoint, but you'll see that that tends to fluctuate to a degree based upon the degree to which enforcement is conducted. And so as an example, hypothetically, at least, it's always been argued that enforcement is a bit more stringent in Ohio versus Michigan. And as a consequence of that, we have actually done paired studies on the same roadways cutting across the 2 states. And we have generally found, all other things being the same, that speeds were a little bit lower in Ohio, interestingly. And likewise, if we monitor speeds during some of the periodic or regular enforcement programs, we do see that there is a measurable impact, at least while those campaigns are ongoing. Now, it's a measure of debate how much maintained effect those programs have over time. But beyond that, other enforcement programs that have proven successful would be examples like You Drink, You Drive, You Lose, and some of these efforts that are focused on mitigating drunk driving or distracted driving. Now, one important piece there that sometimes is a bit of a missing link is adjudication. So once those citations are issued or the person goes to court, what happens to that? Do they receive the full charges? Are they fined? What basically happens as a consequence of that? And so there's actually an ongoing study through the Behavioral Traffic Safety Cooperative Research Program, or the BTSCRP, that is focused specifically on that very issue. So understanding where there are barriers, and for example, charges may get pled down to lesser offenses. And while that's more convenient and efficient from a court perspective, there are certainly some negative repercussions on traffic safety as a consequence. The EMS community is largely serving in a supporting role, and that would include both responding to crashes and injuries when they do occur, as well as leading efforts to clear incidents so that we don't have any secondary crashes occur from vehicles that are approaching a downstream crash, vehicle breakdown, whatever the case may be. So as you can see here, there's a broad range of different activities that can be used to improve traffic safety. And while each of these on their own have been shown to have meaningful and substantive impacts, really we're looking to leverage a suite of these materials and these methods together in order to get our optimal bang for the buck from an investment standpoint. And so we'll talk more about specific strategies that work well or not so well as we continue through the semester. But that's just giving you largely a high-level overview of some of those activities across the 4 E's. Okay. And so now on to the National SHSP, as we had alluded to previously. So this document was initially developed back in 1997 and most recently updated in 2004. And so by and large, that's relatively recent in terms of thinking about what's happened over time in the traffic safety community. So it took a while to get traction for a concerted, coordinated effort at the national level. And so in concert with the SHSP, the National Cooperative Highway Research Program, or NCHRP, also developed a report series, which is titled NCHRP Report 500, and this is guidance for implementation of the AASHTO Strategic Highway Safety Plan. And so there are numerous volumes that basically address important and emerging issues that have contributed substantially to traffic crashes, injuries, and fatalities, and also countermeasures and proven practices that have been shown to reduce the frequency or severity of these crashes. And so we'll delve into a few of these guides subsequently, but the next few slides will just detail a few of those large-scale issues that are really common across the United States. Okay, and so if we look at the national SHSP, there are basically 6 general emphasis areas, and these areas include a mix of high-risk groups of road users, high-risk driving scenarios, as well as various types of programs and policies that have proven effective in reducing the risks within some of these other areas. And so first of all, from a driver perspective, if we look at the research literature, we see a number of groups that are at particularly high risk for crash involvement. Looking at age, typically the youngest drivers, due in large part to inexperience and higher risk taking, as well as the oldest group, now in this case, due to degradation in physical and cognitive capabilities, tend to have significantly higher risk. So if we look at crashes per VMT with respect to age, we basically see a U-shaped curve where the risks are highest at very young ages, and then they start ramping back up again as people get older. We also see that certain sets of drivers who engage in one high-risk behavior tend to engage in other high-risk behaviors. And so historically, crash rates have been higher among those with suspended licenses or without any type of license. And that's even, when controlling for other factors here. So before and after those licenses are revoked, these groups do tend to still exhibit worse performance from a safety standpoint. Aggressive driving, speeding, not wearing a seatbelt. We tend to find that the same groups of drivers tend to engage across many of these high-risk behaviors. And driver distraction, drowsiness, fatigue have also been particular issues over the last 15 to 20 years as well. Special users, we've already talked a bit about pedestrians and bicyclists, so those tend to be among the most vulnerable groups, and as a consequence, there are a number of strategies that have been implemented with a focus specifically on helping to facilitate safe travel among that most vulnerable group of road users, which would also include motorcycles. Like I've said previously, registration and travel rates have increased significantly in that group, and along with it, the number of crashes and fatalities. Heavy trucks, interestingly, now if you look at the performance of CMV drivers, you'll find that on a per VMT basis, they're absolutely the safest drivers on the road. Unfortunately, when those vehicles are involved in crashes, it's often the fault of the other drivers, and the drivers of those other vehicles tend to sustain very severe injuries as a consequence, just given the difference in mass across those vehicles. And so as we think about that, heavy trucks also have a major influence in how we design roads due to the fact that they don't have quite the same XL, decel, and turning capabilities of passenger vehicles, for example. Continuing on the design side of things, there are various types of obstacles that have been shown to be major problems for drivers: trees, utility poles, other objects on the roadside. The AASHTO Roadside Design Guide provides guidance in terms of what we should try to do in terms of mitigating some of these issues, with the first preference being either removing these obstacles whatsoever, or in the case of something that can't be removed, like a culvert, extending that further out beyond the clear zone, or placing some form of barrier to prevent vehicles from running into these objects. There have also been a number of countermeasures aimed at preventing certain types of crashes, and so centerline and shoulder rumble strips have been used as a countermeasure for runoff road crashes. We've seen various treatments applied at unsignalized intersections, so different types of warning systems to try to mitigate the potential for angle crashes and other crashes that occur at, say, two-way stop controlled intersections where the risks of injuries and fatalities are quite high. Head-on collisions, the centerline rumble strips again play a role there, as do things like cable median barrier on high-speed facilities. And there continues to be quite a bit of effort in work zone safety, and that's oriented both towards maintaining safety among drivers and vehicle occupants traveling through those work zones, as well as among the workers themselves. And that includes several work zone safety grants that we've been engaged with here at MSU. We've touched on EMS largely in a support role, and that's particularly important in a rural environment where response times are higher. And then management plays a big role as well. And if we look over the last 20 years, there have been huge advancements in terms of the quality of the data systems that have been developed to support safety management activities, as well as the integration within and across these different data sources. So in some states, for example, we can link crashes with traffic volumes and with roadway characteristics and with driver training and licensing records and citation records. And the degree to which these systems are integrated varies substantially from state to state, but there are a number of best practices, and Michigan tends to have some of the better data systems when compared to some of our peer states, as we'll talk about further. Okay, now continuing on, the SHSP, in addition to identifying these emphasis areas, has highlighted a number of different implementation strategies. Now, I won't read through all of these, but we will generally revisit a lot of these. over the course of the semester. And so this includes a list of programs that serve as best practices, as well as some of the same emphasis areas you saw in the preceding slide, where there have been a number of targeted countermeasures that have been developed and have proven to be effective, largely through research studies as an example. And so we'll delve into these in greater detail at various points over the course of the semester, but this just highlights and reinforces a lot of the same themes we saw in the preceding slide. Now, if we turn here to Michigan, our most recent update to the Strategic Highway Safety Plan would have occurred a couple years ago. And Michigan is one of numerous states that adopted a goal of TZD, or towards zero deaths. And so if we look nationally, the goal that was established in the mid 2010s was to basically reduce traffic fatalities by half by calendar year 2030. And now that's quite an ambitious goal. And frankly speaking, I have serious doubts as to whether we'll achieve that goal. But with that being said, it is important that we establish targets that are somewhat reasonable, but also aspirational. And so to that end, as I had alluded to previously, back around the same time period, we had assisted the Office of Highway Safety Planning in developing some targets for calendar year 2016. And so what you see right here is basically a plot that shows snapshots of how fatalities and serious injuries had varied over time. And as you see, particularly from 2013 to 2014, we saw some significant reductions. And so we had met with some stakeholder groups and basically outlined what we believed to be reasonable targets for several years down the road. Now, interestingly, in looking at this, these values were adjusted in 2016 to correspond to 2018 goals. And you'll notice the fatality number is basically going in the wrong direction here. And so we had reached a modern low of, a near modern low of 836 in calendar year 2014. Unfortunately, travel numbers had rebounded and other factors had led to those numbers going up. And so rather than setting a more aspirational target, we actually set up a threshold that we didn't want to exceed 967 fatalities. In contrast, we did continue to see some improvements in serious injuries, and so that number was ratcheted down to a target of 4,600. But this reinforces some of the challenge in these data-driven approaches, in that there's so much randomness and uncertainty associated with the process. Things like how much people travel, what economic conditions are in place. And so trying to forecast safety at a local level or more globally is just a very challenging exercise. And we'll talk about some of the reasons for that and ways that we can try to account for some of these effects that may cloud our potential judgment in establishing these targets as we move forward. Okay, this next slide here is just basically showing us a snapshot as of when we had conducted our review in 2014 for which states had adopted towards zero deaths as a policy at that point, as well as specific goals or targets that had been established on a state-by-state basis. And so as you can see here, the vast majority of states had adopted TZD as a strategy at that point, and now virtually every state has adopted similar programs with those types of goals. And beyond that, as we look at the goals from state to state, you'll notice some just have an absolute, zero death end goal, while others have introduced some preliminary benchmarks based on some of the types of forecasts we saw in the preceding slide there. And so consequently, we'll look to revisit some of these issues and see how some of these targets have changed over time. But this just gives you a snapshot of some of the early adoption of some of these TZD principles. Okay, so here in Michigan, you'll notice we see many of the same emphasis areas that we see in the national plan, and the same thing is true as a part of that same study. We had contrasted what the emphasis areas were state by state across the US, and we saw a lot of commonalities there. From a behavioral standpoint, here in Michigan, you've probably seen a lot of enforcement programs focused on distracted driving, drinking and driving, and seatbelt use are the three most prominent that are run by OHSP on a regular basis. We've also had efforts focused on some of those at-risk driving groups we had talked about previously. So PEDs, bikes, motorcyclists, older and younger drivers, and then commercial vehicles, well, not necessarily those drivers themselves, but other vehicles operating around large trucks. From an engineering perspective, for years there was an engineering action team and a lane departure action team, as those were two of the primary types of crashes that tended to be problem areas. So a bulk of crashes and fatalities occur at intersections, and others as a result of runoff road crashes. Those groups subsequently coalesced into a traffic safety engineering action team, or TSEAT, with whom you'll become more familiar over the course of the semester. And so that group meets on a roughly quarterly basis to talk about some big picture efforts aimed at addressing some of these problem areas. And the same thing is true across some of these other groups as well. So there are dedicated action teams that have been developed by OHSP in partnership with MDOT and the EMS and education communities. And in addition to that, we talked previously about some of the systems that have been developed here in Michigan, including things like Michigan Traffic Crashfacts.org, which is a great resource. And there are a host of other data that are available through an OpenGIS portal, for example. And so MDOT and the state of Michigan continue to be leaders in that domain. Now, turning more to a narrower focus on the engineering side of things, one of the requirements as per MAP 21 was that each state was required to submit an annual Highway Safety Improvement Program report. Now, the Highway Safety Improvement Program was developed as a national best practice back in the late 70s, early 80s. And basically, that program is comprised of efforts that are aimed at improving safety through engineering actions. And so MAP 21 basically introduced three requirements. First, that states are required to describe the progress that's being made to implement highway safety improvement projects. And so on an annual basis, there's basically a set aside of funding, and states use that funding for dedicated projects that address safety issues that have been documented through data-driven approaches. And so this would include the costs of those projects, details of when and where they were implemented, and states are also required to assess the effectiveness of these improvements over time. And so the way that's typically done would be looking at averages, say 3 years before and after in terms of crashes, injuries, and fatalities, using data from the locations at which these projects were implemented. And then lastly, this report needs to describe the extent to which these improvements have helped the state to meet some of those goals in terms of reductions in fatal and serious injuries, as we had talked about at a high level in the SHSP. Okay. And so to that end, it's important that there's consistency between those respective documents. And so generally speaking, we have strong involvement of engineering in the SHSP development, but then at the boots on the ground level, we want to make sure that there's consistency in terms of how DOTs are approaching this versus how the state is approaching these issues at a 50,000 foot perspective. Okay. And so the HSIP basically has three general functions. The first of those is at the planning level. And so basically states want to collect and maintain safety data. The most critical element there would be crash data so that we have a sense of where problems may exist. But we also need to be able to relate that crash data, preferably geospatially, to roadway characteristics. So cross-sectional characteristics, lane widths, shoulder widths, clear zone, horizontal alignment, vertical alignment, traffic volumes, anything that could potentially help us to quantify or explain some of the trends that we're experiencing from a safety standpoint. Now, using those data, states are tasked with basically identifying and prioritizing high risk or hazardous locations. So basically those sites that experience a disproportionately high number or severe high rate of severe crashes as compared to similar locations. Being able to identify such locations would then prompt us to conduct one of a number of different types of engineering studies, like a road safety audit, for example, and trying to identify whether there are countermeasures that would make some of those crash problems at individual locations correctable. And in establishing some of those potential projects, we then would want to be able to prioritize based on whatever pool of funding we have available, which of those are implemented on 1, 3, or 5-year time horizons, for example. Once those planning activities have been completed, we would typically implement those projects. And so from a scheduling standpoint, transportation improvement plans, we're typically looking at a time window of maybe 3 years there. And we still want the ability to be able to adapt. So as sites or concerns begin to emerge, we'd have some flexibility on a year-to-year basis. But generally, given the time involved in project scoping and planning and programming, it is a rather long process. And so it does take some time in order to get these projects scheduled and constructed. And then lastly, once we've actually implemented the project, it's imperative that the states are able to assess performance over time. And so as a part of this, documenting what works well, where things could be improved, are there countermeasures that haven't worked as effectively as we may have hoped? And so ultimately, this ends up being somewhat of a cyclical process where after the evaluation step, that kind of feeds back into planning, for example. It's also important that HSIPs are science-based. And so again, this ties in very much to the Highway Safety Manual. And so we've seen significant advances in our ability to quantify with a reasonable level of accuracy and precision what impacts we may see on traffic safety for different types of roadway improvement projects. Okay, so largely we're looking at empirical data for similar types of studies, and we can get somewhat reliable estimates depending upon how frequently these types of crashes occur and how frequently we've applied the countermeasures as to how effective we would expect they may be at similar locations over time. Okay, and so as a part of that, that's an important benchmarking procedure on an annual basis, and we'll talk more about this, but for example, if we ranked locations based on the number of crashes that occurred, we'd tend to see all the high volume sites would just come to the top of that list. So it might make sense for us to compare within groups of roadways with similar volumes and or similar geometric configurations, whatever the case may be. And then on that basis, we're trying to better understand how effective these improvements are that we potentially have to use in our toolbox. And so ultimately, as I had alluded to, that helps us to inform future decisions, as this tends to be a cyclical process, largely as you see illustrated right here. And so this basically is just a schematic that kind of reinforces how the SHSP and HSIP complement one another. And so to clarify, the SHSP is basically a high-level plan that's been developed by engineers in consultation with a wide range of other stakeholders that's led to the identification of problem areas, effective strategies, and insights into where prioritization is most appropriate. And so the HSIP is essentially a breakout for the engineering piece of that. And so you'll see there's a natural alignment between each of those levels of the SHSP and the HSIP. And you'll also notice, importantly, we basically have a feedback loop here. And this is where we become particularly important from the university standpoint, is we help with the feedback and the updating of design standards and data-driven decision support tools, for example. And so over the next few lectures, we'll begin talking about some of the inputs to this process, particularly some of the data elements, and provide you all with an understanding, at least at a macro level, of how this all fits together in order to try to optimally deploy our scarce resources for roadway safety improvement. Okay. And so that wraps up today's lecture. A quick reminder that our first assignment is due this Friday, and that focuses on the identification of 2 high-risk locations. And then, as I had noted, when we come back for the next lecture, we'll largely be talking about data, starting first with crash data, including how it's collected, familiarizing ourselves with Michigan's UD10 crash report form, and talking about the Model Minimum Uniform Crash Criteria, or MUC, which has been established to help guide states in the development of their own crash report forms and crash data systems. Thank you.